Welcome to our continuing discussion of IPv6. In this module, we're going to talk about address types and scopes. Remember, when you have questions, use the question comment box at GoGo. Let's get started. Module topics are Unicast addresses. We'll take a look at the construction of a unicast address seen in IPv6. We'll talk about the change in how multicast addresses are used in IPv6. And we'll talk about a new player here called the Anycast address. And we'll go through some of the initial steps here in address notation. In IPv6, three types of addresses exist. And they are unicast addresses. Generally, this is an address we'd see for typical communications, that is, point-to-point type of communications. Multicast addresses. They're similar to IPv4 multicast. However, we have eliminated, or the standards committees have eliminated, the existence of broadcast addresses in IPv6. So multicast processes will be used instead of a broadcast. The idea is to prohibit the amount of excessive traffic that would exist in broadcasting. So using multicasting, since when we use a broadcast address, do we really need to have that information to everybody in the world? Obviously the answer is no. So broadcast still exists, though, in Ethernet layer 2, especially in address resolution protocol. The Anycast address is new to IPv6, and we'll take a look at it in a little more detail right now. Right? An address identifier is for a single interface. It's not for the device. In this case here, if we're looking at a desktop machine, a tower, then we can have multiple interfaces associated with this particular device. The unicast address, as we mentioned, is used for point-to-point communications. The unicast addresses are associated with a single network interface card. So we're showing here that we could actually have different interface cards with a particular box. IPv6 addresses are assigned to interfaces, not to the devices of nodes. So an interface can have multiple unicast addresses. Now let's take a look at the globally unique unicast address scheme right in here. You'll notice that according to the assignment agency, then the range generally starts with a 2001, and we do have others that were approved later. These were done, you see, back in 1999, these in the early part of the first decade here in the year 2000. And then we will see other extensions, other things added depending on the need for these addresses. So what are the INA assignments here? We have different areas covered for the different registries associated with the IP addresses. So we see a listing there covering all parts of the world. So, multicast addresses. In multicasting, an identifier is set for a group of interfaces. And normally this applies to different devices. I guess it wouldn't make any sense to have these double interfaces on the same device get the same message. Although perhaps there could be a system, an instance in which that would be true. So a packet, a multicast packet, would be sent via multicast address, and this would be then delivered to all interfaces identified by that multicast address. So devices then, by having a same multicast address, become members of a multicast group. So all devices in the group use the same multicast address assigned to one of their interfaces. So a multicast group can be assigned to users in a work group, throughout the enterprise, or even globally, I guess. An Anycast address. It's an identifier for a set of interfaces and is assigned to different devices. So a packet sent to an Anycast address is delivered to one of the interfaces identified by that address. So this is a departure from what we saw in Unicast and Multicast. the nearest one is chosen. And how is that chosen? Well, that's chosen based on the routing information that's available. So the nearest one would be assigned according to a routing protocol. So an example, if we had mirrored DNS servers, then what we would have is information sent to the nearest DNS server. Well, what are scopes? Scopes in IPv6 talk about to relate to the topology or the geography. Where in the overall network environment is this address to be used? So, for example, a particular address may be used only on a local link. And every IP address, other than the unspecified address, which remember is all zeros, has a specific scope. And that defines the topology in which the address is unique. And all that means that it defines the topology in which the address is unique and can be used. So the scope of an address is part of the address. Scope can be resolved by looking at the higher order bits of an address. So unicast addressing will have global scope. It means if it's globally unique, then there shouldn't be any problem of using it anywhere to communicate. Uniquely identifies the interfaces globally. Recognized as routable addresses by internetwork routers. And that's a very important distinction that other addresses do not have. So a link local scope identifies an interface on a single link and would be a non-routable address. Anycast addresses are allocated from the Unicast address space. Same scope as Unicast addresses. Can be global or link local. And there are defined 14 different scopes for multicast addresses, and we'll take a look at those in more detail later. What about the address structure? A very important thing here in IPv6 was picking up a dramatic increase in the number of possible addresses and learn from our shortcomings with IPv4 addressing. But the expansion here by the power of the fourth over what we had in v4 then gives us a phenomenal number of addresses, and we can't relax our guard. We still need to have a structure in the way addresses are assigned. So if we had 6 billion people on the earth, then everybody has a whole pile of addresses that are available to them. It shows that we have the possibility, and as a result, remember we talked about some address space will be reserved, so we still need a well-designed format for assigning the addresses. Addresses are now written in hexadecimal form, and address allocation mechanism provides a significant flexibility in network configuration. So the address notation, remember, is 128-bit addresses, and we talked about this previously. So we have a shorthand that's used. Here we have an address with a significant number of zeros, and we can use the colon separation designation here, separating groups of 16 bits or 4 hex characters. And collapsing zeros then allows us to simplify the notation, and using the rules that we established earlier, the above address then becomes what you see on the screen. Well, you have any questions? Well, if you do, use the question comment box and let us know. Thanks for joining us. See you soon.